Hello my esteemed viewers. In this video, I'm going to find the value of x given this equation. Now, I'm not only going to find the value of x, I'm also going to prove whether that value of x is correct, and that is where the interesting part really is. So make sure you watch this video till the end. Let's start. Given x with the square root of x and then square root of x again is equal to 2. Let's get the value of x. So the first thing I'll do is to remove this radical, this square root. So if I remove that square root, I will have to square both sides, because square and square root, they are opposites, they are inverse. So square will cancel the square root. Now I'm going to square both sides. Let's do that together. So square both sides. That will be x root x all squared is equal to 2 squared. Now I'm going to distribute this square to x and to what I have here. See what I mean? It's going to be written as what? X squared and then what? Root x all squared. This is equal to 2 squared. Observe again, square will cancel this square root. And what am I going to have? X squared times x root x is equal to 2 squared. Now from here, what's going to be the next thing? I still have a square root that has to go. I have this. But before I remove that square root, let me apply the law of indices here. Look at this, x squared and x. Notice something, x has an exponent of 1. So from the law of indices, if you have a common base and you're multiplying those two numbers, you are going to add the exponent. So this is going to be x root to power 2 plus 1, all right? Then root x is equal to 2 squared. So what is 2 plus 1? That's 3. So I have x cubed and root x is equal to 2 root to power 2. It's now time to get rid of the square root that is hanging here. So again, the same thing we did, I am going to square both sides. So let's square both sides again. X cubed root x all squared is equal to 2 squared all squared. Very good. Now again, like what I did, I'm going to distribute this square to the individual factor in the brackets. So I'm going to have x cubed times or root power 2, then what? Root x root to power 2, all is equal to what? Now, I'm going to use the power of a power rule in indices. If you have a raised to power m, raised to power n, this can be expressed as a raised to power mn. You multiply the exponent and then you have mn. That's exactly what I'm going to do here. So notice this now, 3 times 2 is going to be 6. So x raised to power 6 and then root x raised to power 2. What is this now? This is 2 times 2, and that's going to be what? 4. So 2 raised to power 4 here as well. What do I do next? This square will cancel the square root, and I'm going to have just x there. So that will be x raised to power 6 times x is equal to 2 raised to power 4. Now what am I going to do next? Again, using the law of indices as I used before, the product rule, the same base, I am going to add the exponent. So I'll have I have 6 and then 1 added together. So I'm going to have x raised to power 6 plus 1 is equal to 2 raised to power 4. And what is 6 plus 1? That is 7. Is equal to 2 raised to power 4. So I'm trying to get the value of x. What can I do to get rid of the power of 7? I will take the 7th root of both sides. Let me say that again. I will take the 7th root of both sides, which can be expressed like this. Now watch this. This is the 7th root. Because one of the laws of indices, if you have a raised to power m over n, this n, which is the denominator, is the root, while the m here is the power. So that's exactly what I'm doing here. Even if I write it like this, x raised to the power 7 with the 7th root like this can also be expressed as x raised to the power 7 divided by 7, since this 7 is the 7th root, as you can see right here. So I have taken the 7th root. I'm going to do the same thing on the right hand side. So 2 raised to the power 4, then what? Times 1 over 7. Because if you take the 7th root here, you must do the same thing on the right hand side. So the reason for that is to cancel the power of 7, and I've just done that. So I'm just left with x, which is equal to what? 2 raised to the power. See, 4 times 1 over 7 is 4 over 7. And I can even rewrite this like this. I just told you about the law of indices, where the numerator is the power and the denominator is the root. So I can rewrite this as 2 raised to the power 4, which is what? 16. So 16 raised to the power of what? 1 over 7. You can use this or use this, but I want to end it with this because we're coming to the interesting part where I'm going to substitute the value of x back into the original equation. And let's see if we're going to have 2 on the right hand side as we have in the original equation. So let me just rewrite the equation, which is x root x square root of x. Let's see if this will give us 2 when we substitute x for what? 16 raised to the power of 1 over 7. So let's get started with this. Now, what is x? We are using what? 16 raised to the power 1 over 7. The square root of 16 raised to the power 1 over 7. Square root of what again? 16 raised to the power 1 over 7. This is going to be really interesting. I just told you about a law of indices where you have fractional index. For example, a raised to the power m over n. I told you that the n is the root, while the m here, which is the numerator, is the power. Why am I saying this? It's going to be super useful as we simplify or as we work this out. So I will not be writing is equal to 2 because I'm trying to test if I'm going to have 2 when I work this out. So let's do that together. Now let's start with what we have inside here first. What do I have? Square root of what? 16 raised to the power what? 1 over 7. Remember, this square root can be expressed as the power of 1 over 2. Don't worry, let me just rewrite this first. 16 raised to the power 1 over 7. Square root of what? 16 raised to the power 1 over 7. Then I will not be writing this anymore. I'll be writing 16 raised to the power 1 over 7 times 1 over 2. See, 16 raised to the power 1 over 2 is the same thing as square root of what? 16. This 2, which is the denominator, is the root. So I no longer wrote the square root. I now express this as a power of 1 over 2. Still using the same fractional index law I talked about earlier. Okay? So let's go ahead with this. I'm going to have 16 raised to the power 1 over 7 square root of what? 16 raised to the power 1 over 7 and then 16. What is this? See, 1 over 7 times 1 over 2 is 1 over 14. Yeah, 1 over 14. So I have in this square root, I have 16 raised to the power 1 over 7 and 16 raised to the power 1 over 14. What do you think I can use here now? Of course, the product rule in indices. They have the same base of 16. I'm going to add their exponent. So this is what? 16 raised to the power 1 over 7 square root of what? 16 raised to the power 1 over 7 plus 1 over 14. So let us simplify 1 over 7 plus 1 over 14. If you add these two fractions, give it a common denominator. So 7 goes into 14, 2. 2 times 1 here is 2. And this 14 into 14 is 1. 1 times 1 is 1. So I'm going to have 3 over 14 when I add these two fractions here. Okay, let's rewrite that. So that's 16 raised to the power 1 over 7 square root of what? 16 raised to the power what? 3 over 14. Notice from here. Very good. So what am I going to do next now? You guessed it. I am going to remove this square root and express it as an exponent of 1 over 2, like I did earlier. So I'm going to rewrite this as 16 raised to the power 1 over 7, then times 16 raised to the power 3 over 14 times 1 over 2. 1 over 2 because I no longer wrote the square root. I have rewritten it as what? An exponent of 1 over 2. Very good. So what am I going to do next here? I am going to multiply these two fractions. So I have 16 raised by 1 over 7 times 16 raised by what? What's 3 times 1? That's 3. And 14 times 2 is what? 28. Okay, again, use the law of indices, the product law of indices. They have a common base of 16. I'm going to add their power. So 1 over 7 plus 3 over what? 28. We can make them have a common denominator of 28. 7 into 28 is 4. 4 times 1 is 4 plus 28 into 28 is 1. 1 times 3 is 3. So you have 7 over 28. So I'm going to rewrite this as what? 16 raised to the power of what? 7 over 28. Let's simplify this. 7 here is 1. 7 here is what? 4. So I have 16 raised by what? 1 over 4. And what did I tell you about a fractional index? This denominator is the root, while the one here is the power. So this is what? The fourth root of 16. And what is the, or you can write all raised by 1 from the 1 here. So what is the fourth root of 16? It is 2, because 2 times 2 times 2 times 2 is 16. So we have just proven that the value of x is truly what? 16 raised to the power of 7. Because when we put it back into the equation, we got 2 on the right hand side, as was the case in the original equation as we have right here. So the value of x that will satisfy the equation is what? 16 raised to the power of 1 over 7. I'm sure you enjoyed this video. Kindly subscribe to this channel. Make sure you like and share this video to your friends and family. I hope to see you in the next one. Bye for now.